When adding and subtracting rational expressions with binomial denominators, you need to find a denominator that includes all of the factors in the denominators. If I put brackets around these, it makes it easier to determine what the factors of the denominator are. So one of my factors is n plus 4, the other factor is n minus 5. That means the denominator is going to have both factors, so it's going to be n plus 4 and n minus 5. So both fractions are going to have both of those factors in their denominator. In order to make this an equivalent fraction, what I need to look for is which factor in my denominator is not present in the original question. So I have an n plus 4, but I don't have an n minus 5, so I'm going to need to include that in the numerator as well. So I have 4n times n minus 5. Same thing on this one. The denominator already has an n minus 5, but it didn't have an n plus 4 to begin with, so I've got 3n. And then n plus 4. Now I've created equivalent fractions with a common denominator. The next step is I'm going to expand. So I'm going to get 4n squared minus 20n all over n plus 4 and n minus 5. On this side, I'm going to have 3n squared plus 12n, and I'm also going to have n plus 4 and n minus 5. Now my last step is just to collect my like terms. So I've got 4n plus 3n. It's going to give me 7n squared. Negative 20n and positive 12n is going to give me negative 8n. And my denominator is n plus 4, n minus 5. I can figure out the non-permissible values by looking at my denominator. From this one, it's going to be n cannot equal negative 4. And from this one, it's going to be n cannot equal positive 5. Sometimes I have to factor in order to figure out what my denominator is going to be. If I factor the denominator in this question, I've got x minus 6 and x plus 6. If I factor out the denominator in this question, I can factor out an x, and I'm left with x minus 6. So now I need to create a denominator that includes all of the factors. I've got a factor of x minus 6, a factor of x plus 6, and a factor of x. So my denominator is going to be x times x minus 6 times x plus 6. I'm going to make my second fraction have the same denominator. X times x minus 6 times x plus 6. Now I need to figure out what's missing. In this denominator here, I've included an x that was not in the original one. So I've got a 1, I'm going to need to multiply that by the x. In my second one, the one that was missing, the one that wasn't in the first one, is x plus 6. So I've got a 1, I'm going to have to multiply that by x plus 6. Now I need to simplify. So I've got x minus 6, because this minus applies to everything in my numerator of my second one. My denominator is x times x plus 6, or x minus 6 times x plus 6. Now I need to collect all my like terms. X minus x is going to give me 0, so I'm left with negative 6 on top. The denominator remains the same. Now I could expand this out, but there's no need to. There's no reason at this point that I would need to expand that out. And I know from here that x cannot be equal to 0 from this one, to 6 from this one, and to negative 6 from that expression. Finally, here's one where I have to factor out both denominators again. I'm looking for numbers to multiply to 6 and add to negative 5. I'm going to get n minus 2 and n minus 3. On this side, I've got n plus 4, and this factors into n minus 5 and n minus 6. Now, to make my question easier, I have an n minus 2 on the top and the bottom. I can cancel those out. So my new expression now is 1 over n minus 3 minus n plus 4 over n minus 5 and n minus 6. So my common denominator needs to include all of these. I can leave this in brackets if it makes it easier for me. So my common denominator is going to be n minus 3, n minus 5, and n minus 6. So for this one, I need to figure out what was not in the bottom originally. It was obviously n minus 5 and n minus 6. So I'm going to put that on the top. Now when I multiply by 1, the 1 doesn't actually do anything. So I can just leave it like that. Now on my other side, I had an n minus 5 and an n minus 6, but I didn't originally have an n minus 3. So that's going to have to go on the top as well. So I had n plus 4 to begin with, but I'm also including an n minus 3. Now I need to multiply out my numerators because I'm going to want to collect any like terms. So n times n is going to give me n squared minus 6n minus 5n plus 30 all over my denominator. On the other side, when I expand it out, I get n squared minus 3n plus 4n minus 12 all over my denominator. Oops. N minus 3, n minus 5, and n minus 6. Now when I'm doing these, I find the easiest thing to do, because this is subtraction, so I don't forget signs, I'm going to change that to plus, and I'm going to change all of the signs in my second one. Just because then I'm not going to forget that that negative's there. Now I just need to add. So n squared minus n squared is going to give me 0. The n's are gone. Negative 6 and negative 5 is negative 11. Plus 3 is negative 8. Minus 4 is going to be negative 12n. And then I've got 30 plus 12 is going to give me 42 all over n minus 3, n minus 5, and n minus 6. Now, there isn't any way to simplify this. I could factor out a value out of the top if I wanted to, but it's not necessary. I don't need to. I could factor out the 6, but it's not really going to help me that much. So all I'm going to do is indicate my non-permissible values of 3, 5, and 6, and I'm finished.